Hi, and welcome again to Great Expectation Tuitions. I'm Mr. John Ryan, and I'm going to be dealing in this video on our series of non-right angle triangle solutions, and today we are going to look at proving the cosine rule, which is used in the solution of these triangles. So let's get started. Right. In order to prove the cosine rule, we need a little bit of pre-knowledge, which we call polar coordinates. Let's see what we mean by this. If you look at the diagram, we have a Cartesian plane, and I'm going to call this my angle A in the standard position, B, and C. Now previously we used to name the coordinates of C, X and Y, which is correct. Now we can rename these coordinates in terms of a trig ratio by referencing it in terms of angle A. And how we go about doing it. We know that this side is X and that side is Y. By definition, and we know that this is our hypotenuse, which is AC. Now we can also call this side here AC R as the radius. So we have X over R is equal to cos of angle A. So by cross multiplying, X is equal to R cos A. Similarly, Y over R is equal to sine A. Y is equal to R sine A. So we have renamed our coordinates in terms of what we call polar coordinates. So point coordinate C is referenced as R cos A and R sine A. So whenever we want to write our coordinates in the Cartesian plane in terms of polar coordinates, it's the radius times, for the x coordinate it's cos, and that makes sense, and for the y coordinate it is sine. So this is what we use as our pre-knowledge in proving the cosine rule. So let's get started with the cosine rule. Now that we've got familiar with polar coordinates, let's now look at the cosine rule and its proof. Now the cosine rule states that in any triangle ABC, a squared is equal to b squared plus c squared minus 2bc cos A. If you look at the figure alongside and make sense of that, if that is A, B, C, we know how to name the sides. That's B, small letter A, and small letter C. So we are stating that A squared is equal to the sum of B squared plus C squared minus 2bc cos of the angle between the two sides in order to find A. And likewise, if we want to find B, then we use B squared is equal to A squared plus C squared minus 2bc cos of the angle B. So let's look at the application, the proof of this. And as you know, we can see that there are three forms of the cosine rule. The one used is determined by what is given or what is asked. the side you start with in the cosine rule is opposite the angle you will use in the rule. Now a typical question would look like this. In triangle ABC, prove that a squared is equal to b squared plus c squared minus 2bc cos a. Now you may be given two types of diagrams in the exams. One is the acute case, which is the first diagram, and on the right hand side we have the obtuse case. Both the proofs will apply to both the diagrams that I'm going to do. So first thing, I'm going to label my sides, my angles and sides. If we look at the diagram, since we have to prove find a squared in the triangle and we've got cos a, we put angle A in the standard position, angle B, and we label this as angle C. In dropping a perpendicular from B to AC and calling this point D, we are able to find the coordinates of B using our polar coordinates. We know that is letter A, that's small c, and this is small b. As we did in our previous example, in our prerequisite, we see that the coordinates of B will be the radius times cos of A, and the y coordinate will be the radius times sine of angle A. So here the radius is given by c, so it is c cos A c sine angle A. So we've got our coordinates for point B, which is the first part in devising our proof. Our next point is to determine the coordinates of point C, and as we can see, the x value of point C is given by value B. So that's the x value is B, and obviously the y value is 0. Now let's proceed and look at the proof of the cosine rule. We use the distance formula which we learnt in analytical geometry. So by the distance formula, we look at the distance of line BC, and we know that BC squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. We are familiar with this from analytical geometry. So BC squared, if we look at the coordinate B, it is now c cos A minus the x coordinate of C is B, and we square that, plus the y coordinate of point C, which is c sine A minus 0 squared. So how do we simplify this? Well, we can write this out twice. Let's see, cos A minus B into c cos A minus B, because it's a square, plus here we simplify this as c sine A. How do we multiply this out? Well, we use our multiplication of binomials. So c cos A times c cos A is c squared cos squared A. So c That's that. Now c cos A times minus b is minus bc cos A. So we have finished multiplied by the first term. Likewise, we multiply by b, so it will be minus bc cos A, and minus b times minus b is plus b squared. So we have opened up the brackets here. Plus, okay, that's supposed to be a square, so it's c squared sine squared A. Right, so that's one long expression with 1, 2, 3, 4, 5 terms in it. On closer examination, we can see that the first and the last term can be grouped by removing c squared as a common factor, and that would leave us with cos squared A plus sine squared A. BC cos A minus BC cos A is 2 of those, so 2 BC cos A. And we're still left with plus B squared. I'm sure you recognize this. This is our square identities, which sine squared plus cos squared is 1. Plus b squared minus 2bc cos A. Now note that b squared, bc, is in fact our lowercase letter a. So that's a squared, a squared. We can write that there. And if you look at our last line, c squared plus b squared minus 2bc cos A, which we can write as b squared plus c squared minus 2bc cos A is equal to a squared. And this is the proof of our cosine rule. So if you recall, we used our distance formula and then just applied it with the coordinates and simplified our trig square identities and grouping to arrive at what we were given. If we go back, we were required to prove that a squared plus is equal to b squared plus c squared minus 2bc cos A. Okay, so you can look at that proof in the video and see how it works. Now, if we look at the application of the cosine rule, whenever we use the cosine rule, we would apply it in triangles A, B, C, where we're given two sides and the included angle, and we want to find the third side. So given two sides and an unknown and the angle, we can apply the cosine rule. Now let's look. Another application of the cosine rule is if we're given triangle A, B, C, B, A and C there. If we're given three sides of the triangle, we can use the cosine rule also. So for example, let's say in this triangle here, we got angle B. So we got b squared is equal to a squared plus c squared minus 2ac cos of angle B. Now if we're given the three sides, we can find angle B by simply transposing 2AC cos B onto the left hand side, and we're left with A squared plus C squared minus B squared on the right hand side, and we take B squared on the onto the right hand side. So cos B, if we make that the subject, is equal to A squared plus C squared minus B squared all over 2AC. This is very useful in finding the angles given three sides. So for this here, we are given three sides and we have to find the angles. We apply the cosine formula in this way. In this one here, we've got two sides and the included angle. Then we can say B squared is equal to A squared plus C squared minus 2AC cos angle B. You will get familiar with it with practice. Let's look at some worked out examples in order to become familiar with it, and we will look at just application of these rules, the sine rule, cosine rule and area rule, in further videos. Now in example 1, if you look at triangle ABC, we want to find x, which is opposite angle B. We have 47, 55 centimeters and angle B is 48 degrees. So if we are to name the sides, we've got x there, we've got 47 and 55. So x is our unknown, so it's opposite angle B, so we have x squared is equal to 47 squared plus 55 squared minus 2 times 47 times 55 cos 48 degrees, which is a direct application of given two sides and the included angle, and we want to find the third side. If we compute this with the calculator, you find that we need to find the square root of the answer of this calculation here, and x is equal to 42,13 centimeters. So this is a direct application of the cosine rule formula. If you are not sure about this, let me break it down. If you look at number 1, we want to find x. So if we look at that figure there, there's A, B, C. This is small c, small letter A and small letter B. So what they have applied is that B squared is equal to A squared plus C squared minus 2AC cos angle B. But our B here was x squared. Our A value is 55. Our C is 47 minus 2 times 55 times 47 cos of 48 degrees. So that is how they have skipped a few steps in obtaining the answer there. Now in example 2, we want to determine the value of x, which is the unknown angle. Let's look at this example. So if you look at the diagram, that would be your A, that's your B, and that's your side C. Then we learned from our previous knowledge that if you want to find cos of A or B or C, we can apply it using three sides. So here, if you want to find cos of C, we can see that it's equal to b squared plus a squared minus c squared over 2ba. And if you look at that there, it's equal to b squared is 36, or 29 squared plus 25 squared minus 36 squared all over 2 times 29 times 25. If you look at the solution alongside, there we are here, cos of x and we have the three sides in the calculations. You get a ratio 0,11724, and we know that we use our shift function to arrive at the angle. So learners, as you can see, the cosine rule and its proof, and how do we use it in its application. In our further videos, we will be looking purely at application of the sine, cosine and area rule. Bye for now.